Hello, everyone, and welcome to this quick take. My name is Alba Rivas. I am a developer advocate at Salesforce, and today we're going to take a look at the basics of SOQL, the Salesforce Object Query Language. To understand why SOQL is needed, we need to first explain the concept of multi-tenancy. So that is what we are going to do first. The Salesforce platform was created following a multi-tenant architecture. That means that the underlying resources are shared by multiple tenants, multiple customers, and this includes the database. So imagine that there is a generic huge database in which data from multiple organizations is stored. We can have data from organization 1, organization 2, or organization 3. That means that you as a developer cannot use SQL to directly access that database. What we do is that we give you something called SOQL, the Salesforce Object Query Language, so that you can write your queries. Then those queries go through the query optimizer, something internal that is transparent to you and that is going to transform your queries into real SQL. And then that SQL is going to be executed against the database. In contrast to other database query languages, SOQL cannot be used to modify the records on the database. You only use SOQL for read operations, and you use another language called DML, Data Manipulation Language, to create, update, or delete records from the database. To illustrate how SOQL works along this quick take, we are going to use a pair of custom objects. We are going to use a custom object called species that represents plant species, and we are going to use another custom object called plants that represents plants of a certain species. In Salesforce, you relate objects using lookups or master detail relationships. This is equivalent to foreign keys in other database systems. They are just fields that help you relate to a different object. In our case, plant will have a lookup to species. This is species will be the parent and plant will be the child. Let's start by taking a look at a very simple query. Let's examine the different sections of the query. First, we have the select keyword. The select keyword allows you to specify the fields that you want to retrieve from the database. In Salesforce, you have to specify the fields that you want to use in Apex later, and the only one that is returned by default is the ID field. Second, we have from. From is compulsory because it indicates the table from which you want to query those records. In our case, the plant object. Optionally, you can add some more keywords. For instance, you can add a where clause in which you add a filter to filter by certain conditions. You can also add things like order by to change the order in which the records are returned, and also limit to limit the number of records returned. To try out your queries, you can use tools such as the Developer Console or other external tools, but I'm going to show you how to use the most modern tool that we currently have, which are the Salesforce extensions for Visual Studio Code. The Salesforce extension pack includes a tool called SOQL Builder. You can open the tool from the command palette. SOQL Builder helps you construct queries. For instance, let's create a query for our plant object. We will add some fields, such as the name and the acquisition date, and then the constructed query will appear on the right-hand side panel. In order to run the query, you first need to save it into a file. Let's call the file plants.soql. You can visualize queries in two different ways, in the text editor or in SOQL Builder. There is a button to switch between those views. Now let's paste the query that we previously explained into the file and switch to the SOQL Builder view. To run the query in this view, just press the Run Query button. The result will appear on a panel on the right-hand side. To know more about SOQL Builder, watch the quick take which URL you see on the screen. Alternatively, you can run queries by selecting text. Select the text, then open the command palette and look for this command. In this case, you will get the result on the console output panel. So this is a great way to try out your SOQL queries, but normally you will call queries from Apex. All standard and custom objects have an equivalent data type in Apex. This means if you have a species underscore underscore C custom object, in Apex you will have a species underscore underscore C type that you can construct and to which you can assign field values. Those data types are also used to store the records returned by SOQL queries. To execute a SOQL query, you enclose it in brackets and you assign the result to the list of subjects. This is an Apex code that I have created, and I'm going to show you another tool in Visual Studio Code to execute anonymous Apex. This time, what we will do is to select the Apex code that we want to execute, and we will look for a command that says execute Apex with selected text. We are going to execute it, and there it is. Here we have our results. Great. So now you know how to execute SOQL queries in Apex. Let's take a look at how to bind Apex variables into those SOQL queries. First, you define the Apex variable that you want to use, and next, you use the colon notation within your SOQL queries to reference that Apex variable. Let's execute this code again. And there we have exactly the same result as before, but now using an Apex variable. To finish, let's take a look at the ways in which we can bring related records information into our queries. There are two kinds of relationship queries that we can do. Let's start with child-to-parent relationship queries. In child-to-parent relationship queries, you do the main query against the child and then you bring the related parent information into that query. For that, we need to use the relationship field name. You will find that in the definition of the lookup or the master detailed relationship that points to the parent object. In the case of custom objects, what you need to do is to replace underscore underscore C by underscore underscore R for relation. So here we have our child to parent relationship query. We're going to execute this query against the plants object. This is the child object. And we're going to bring the related parent information. This is its species using the underscore R notation followed by the name of the fields that we want to bring. The result is going to be a list of plants, and what we can do now is to loop over that result and take a look at the information not only from the child but also from the parent. Let's execute this query and see the result. There we have. These are the species for the plants that I have in my organization. So now let's take a look at the other way in which we can bring related records information into a query. These are parent to children relationship queries. In this kind of queries, we execute the query against the parent and we bring all its related children information. So what we will need to do to include those children into the query is to use a subquery on the child relationship name of the lookup or master detail relationship field, followed by underscore R. Here we have an example of a parent to children relationship query in VSCode. We are executing the query against the species, which is the parent object, and then we are bringing the related children information using a subquery on the child relationship name for the lookup field. Then we are iterating over the result. First, we will iterate over the species, and for each individual species, we will be able to access to its children, its plants, and print some information from the plants. Let's execute this query and see the result. There we have. These are all our species with their plants. That's all for today. I leave you here some resources, a pair of interesting Trailhead modules, and the SOQL and SOQL reference guide. Thank you so much for watching. If you enjoyed the video, don't forget to like it, subscribe to the channel, and click on the bell if you want to receive notifications of new videos like this one. Bye bye!